The position vector of a point P is 3,4. Given that the point Q is -1, 1, find PQ. Find the vector PQ. Grace and peace to you, and welcome back to my channel. This is Donald Siame, author of Hidden Mathematical Genius Within Adviewed. Okay, so this is the continuation on where we ended on position vectors. So here we want to solve for the vector PQ. And the easiest way to calculate the vector PQ is first to put this in form of a diagram. Okay, so we need to picture this. So we have a position vector of P, that is to say OP. Okay, so we need to start with the origin. So we have something like this, from O to P. So that is the example for the position vector P. So we also need to have the position vector for Q, that is OQ, -1, 1. So it can be somewhere there. Okay, so we can have a Q there. Okay, then we connect Q and P. Now, we are told to calculate the vector PQ. Now, what we should always remember is that you cannot get straight away from P to Q. We need to go back to O, then to Q. So PQ is equal to PO plus OQ. Okay, now PQ is equal to, here we can see that the normal route, we need to start with O, then P. But here we have PO. PO is the opposite of OP. Okay, and in mathematics, if we talk of opposite, it means that is negative. So PO, it is just minus or negative of OP. So we have negative of OP plus OQ. Okay, so PQ is equal to negative OP, that is 3,4. So we have 3,4 plus OQ, that is here we have the point Q. To make the vector position vector Q, so that is OP, you just put this row matrix into a column matrix. Then we have the position vector OQ. So we have -1 and 1. Okay, so PQ is equal to, when we are adding matrices, we add corresponding entries. So 3 will go with -1. So here there is a negative. So you say -3 plus -1. Negative times positive is negative. So here we have a -3 minus 1. A -3 minus 1, we know that same signs, we add and maintain the sign. So -3 minus 1, that is -4. -4 plus 1. So here we have different signs. And when we have different signs, we subtract and get the sign from the bigger number. So -4 plus 1, we get a -3. So there we have -3. So that is the vector PQ. Okay, that is question 3. We go to question 4. Question 4, the vectors RS is equal to -4, 5. Given that the coordinates of the point S are 1, 2. Find the coordinates of point R. Okay, so here again we need to picture this. we're supposed to have position vector R and position vector S. Okay, so we'll say we have let's say this is a position vector S, then we have position vector R, then we connect these two. Okay, so here we want to solve for the coordinates of the point R. So the coordinates of the point R will be gotten from the position vector OR. So we need to find OR. So OR will say OR, it will be OR is equal to OS plus SR. Okay, so OR is equal to OS plus SR. So OS we'll get it from the point R. So we just change this from a row matrix to a column matrix. Okay, so OS is just 1, 2 plus SR. Here we have RS. So SR is just the opposite of RS. So here we're supposed to have a negative. So this should be a minus. It should be a minus of RS. And we know that RS is negative 4, 5. So we have negative 4 and 5. Okay, so we have OR is equal to, here we just subtract corresponding entries or elements. So here we have 1 minus negative 4. So we have minus and negative. What is negative multiplied by negative? Yes, that is positive. So you have 1 plus 4. And 1 plus 4 is, yes, 5. Then we have 2 minus 5. What is 2 minus 5? That is negative 3. So this is the position vector of R. As a coordinates, the coordinates are for the point R, you just write this as a row, a matrix. So R, the coordinates of R will be 5, negative 3. So this is how you perform calculations. Thank you so much for your time.